Our topic vehicle is a 2002 Honda Accord with a 2.3-liter VTEC engine. The anti-lock brake system, or ABS, and the check engine lights are both on, and the system has reverted to conventional brakes. The codes we pulled with our scan tool were an ABS 15-1 and a PO13502 sensor 11 heater circuit fault. It looks like we have two separate problems on this vehicle, and we are going to address them in that manner. The ABS code 15-1 means the right rear sensor has an open circuit. This could mean a break in the wiring in the sensor, the harness, or anywhere in the circuit. This is the wiring diagram for the ABS system. Notice all the sensors centrally connect to the ABS control unit. We will pinpoint test the circuit by first probing the wheel sensors from the ABS control unit. Disconnect the wiring from the control unit. Connect the ohm meter leads to the corresponding pins of each sensor. Three of the sensors read approximately 1,600 ohms of resistance, well within specs. The right rear reads about 2,700,000 ohms, which is nearly an open circuit, just like the trouble code said. Before we dive in and replace the sensor, a verification of the wiring from the controller to the final connector of the sensor is in order. To do this, disconnect the final connector located in the trunk. Connect a jumper wire between the pins on the connector leading to the controller. Now the meter at the controller reads 1.1 ohms of resistance, which means the circuit from the controller to the final connector is good. Next, test the connector leading to the sensor. The circuit reads open, which means the wheel speed sensor is the problem and must be replaced. The wiring to the sensor must take a specific path to prevent it from being stressed or pinched while the vehicle is being driven. Due to the harsh environment ABS sensors are constantly subjected to, it is common for rust and corrosion to seize the sensor into the backing plate. After the defective sensor is removed, the mounting hole needs to be cleaned to make it possible to insert the new sensor. Here's a method to clean the mounting hole you might want to try. Fold a cut coat hanger wire in half and pinch a piece of 80 grit emery cloth in the end. Insert the other end of the wire into a drill and tighten it down. Now, insert the emery cloth into the hole and run the drill. This will remove the rust from the hole to provide enough room for the new sensor to be installed. Even after cleaning the hole, some lubricant may be needed to get the sensor to slide in position. Before installing the sensor, be sure to check the mounting bracket locations. Remember, it is critical for these brackets to be positioned and placed in the exact same location as the original. As you can see, the well sensor is a perfect match. After the installation is complete, be sure to check your work. A check of the resistance from the controller through the sensor reads 1,609 ohms. This is within specs. Checking the AC voltage output from the wheel should also be verified. When the wheel spins, the exciter ring in the hub also turns and moves the magnetic field across the sensor windings, generating an AC voltage. As you can see, we are now generating about 0.4 volts AC just spinning the wheel by hand. When a sensor fails either of these tests, it is defective. The ABS problem is repaired and the code is cleared. The PO135 code concerns the air-fuel ratio or O2 sensor heater circuit. With the lab scope connected to the heater circuit, the digital signal looks perfect. We tried a quick acceleration and the signal momentarily flatlined. The signal should stay constant during the acceleration. After a closer examination, we can see why the flat line occurred. We found out later a clutch had been replaced in this vehicle, and when the sensor was replaced, the connector was never released. causing the wire to wrap around like this, causing an intermittent open circuit in the heater circuit. This sensor was replaced and the code was cleared, and the problem was solved.